All right, in my last video, I set up this question. We're going to take as given the location of the clock crossing event. Right here. T comma x is tau meet comma x sub c, and t prime comma x prime is tau prime meet comma x sub c prime prime. And I wanted to find where t and x is, which is the location of this coordinate in the primed frame. Of course, in the unprimed frame, it's just 0, 0. But in the primed frame, where it's measured from here, tau prime equals 0 and x prime equals 0, it's going to have a different value, and that's what the capital T, capital X is. I've written this in my paper as 1.1, but some of the things in here are renumbered. Okay, so this is capital T and capital X, which is T prime boost and X prime boost, equals negative gamma, and then we got the 1 minus V over C squared, negative V 1. And then the tau meet, yeah, that's one of the variables we already have, tau meet. And X sub C was the coordinate of the clock, the stationary clock C in the unprimed frame. And then we'll also have tau prime meet. That's where the time at which the two clocks meet in the primed frame. And then x prime, I wrote CP prime there, but the prime didn't show up very well in the subscript, so I just wrote CP prime. So this is the position of the primed clock in the primed frame. And really that's our answer. T is a function of tau meet and x sub c and t prime sub meet. So actually I should have written it, let's see, tau meet is there, x sub c is there, and then tau, so it's not a function of x sub c, it's actually a function of tau prime meet, and the other one is a function of tau meet x sub c and x sub c prime. So let's write those out as independent equations. X equals gamma, or negative gamma, times negative v tau meet, plus x sub c, plus tau meet prime. How does that compare? Oops, I'm mixing lines. Hold on. X equals negative gamma times negative v tau meet plus 1 x sub c plus, okay, I just goofed one spot. Okay, plus x prime c prime. So this is the coordinate of the c prime. So that is this equation here, or is it? I seem to have a negative v tau. Huh, he's got a, looks like it's a typo. So this would be x sub c prime, x sub c prime prime, plus, or no, minus. Let's go minus. Then we'd have x sub c minus v tau. And so that looks like it might be a typo there. That c should be a v. Next we have t. Let's go ahead and write out this part of the line. It'll be t equals negative gamma times 1 times tau meet. I'll just write tau for now. Minus vxc minus vx sub c over c squared. And where are we? Yeah, there. Plus tau prime meet. I'll just write tau prime, and so that reordered in the same order there. It's tau prime minus gamma times tau minus Vx, Vx x sub c over c squared. Now you notice he's got chi. He's used chi here for both x sub c. What did I do? I did it again, didn't I? Oh, no, I didn't. For both x sub c and for x sub c prime. So he's got chi in both of those areas. So I'm distinguishing between the x coordinate of the unprimed clock in the unprimed frame and x prime, the primed coordinate, of the primed clock in the primed frame. Those are both constants. Now we'll find out whether that was a typo or a real error in the next step, because he's going to be substituting these values of the constants into 1 and 2 and rearranging. Now this is not quite accurate. He has said that he's substituting values of the constants 1 and 2, but he's doing something else as well. He's actually putting the coordinates of the primed clock into the location. So I'm going to do this in 2 steps. One where I do what he says to do here, and then the other I'm going to plug in the x of the c prime clock. So to do that, I'm going to first just erase all of that because that was just all verification, and just leave that big equation there. All right, I got a bunch of stuff in here. Section 1, equation 1.4, 1.5. I'm going to skip past that and go to the part of my paper where I say, let's do it right. And I said, while the math J.H.Fields has done is essentially correct, I mean, except for the typo it just found, the naming of the variables could be improved. The curious replacement of x sub c equals chi can be undone. We can work out the problem more elegantly for the two clocks c and c prime. So this is what I did. First, 2.1, t prime boost, x prime boost, and that's equal to what he was calling capital T and x, is equal to the Lorentz transformation around, and this is the point, the tau and x sub c of the clock variables, and then we're going to transform those around, I think that's around the boost, around the origin 0, 0, and then we're going to add on the coordinates of the primed variables. So these are new variables. This is I'm sorry, these aren't variables. These are new points. This is a new point in 2 reference frames. This is a shared point where the 2 clocks meet. So we can see what the coordinates of where the clocks meet in the primed frame and where the clocks meet in the unprimed frame. So then we're going to take those 2 points, or no, we're going to take this point, which we've just figured out, and we're going to replace that point right there, t prime boost, x prime boost. And when we do that, this whole thing gets put right here. Yeah, okay, that whole thing, I can write it out completely. We'll cross that out, and it's equal to negative gamma, wow. I didn't make this easy on the reader, did I? Let's write it, switched over to the other version of it. So it's, again, it's cosh phi negative sinh phi over 2, or no, over c, negative c sinh phi and cosh phi times tx. And Okay, I forgot what I was doing. Not tx, tau meet x sub c. I'll just call it tau and x sub c for now, and then plus tau prime and x prime plus tau prime x sub c prime prime. And then, so we crossed that out and just replaced it with this, and that's going to be a minus sign there. Minus. So you can combine combine parts of it. Cosh phi times t minus cosh phi times tau is going to be cosh phi times t minus tau. Negative sinh phi over c times x minus sinh phi over c times x sub c is negative sinh phi over c times x minus c x sub c. Also, we'll go through this one. Negative sinh phi times t, negative sinh phi times t minus negative c sinh phi times tau is negative c sinh phi times t minus tau. And cosh phi times, I think I may have already done all of them. So anyway, we've just taken that tx and tau x sub c and basically subtracted them because this is the exact same thing. And then the plus tau prime x sub c p prime goes like this. Now, what is cool about this is that we've eliminated the tx from the situation completely. What do we have instead? We have something. We can also subtract this from both sides, putting that as t prime minus tau prime meet x prime minus x sub c p prime prime. And guess what? This is now the same rotation, except we've moved the relevant point. We no longer are worried about this, that point tx being the location of the origin of the unprimed frame. What we're worried about now is just the shared origin, this place where the two clocks are meeting. It doesn't matter what their coordinates are, we can just say that those two clocks are meeting there. So all of these 3 points are still relevant. We've got 3 points here. One here, that's the origin of the unprimed frame. One here, that's the origin of the primed frame. And one here, that's the point where the two clocks meet. The only thing is we made it a little bit nicer by making it so the relevant point is also the point where the boost happens is also relevant to the problem, because the problem is about where the two clocks are meeting. But it's kind of weird because now both origins are going to be moving around when you do the transformation. But the clock point will stay stationary. All right, now the words here, substituting these values into the constants into 1 and 2 and rearranging gives these equations. Now, that's not accurate. What the equations should have been, if you did what he said there, it should have been this. There should have been a t prime, an x prime, a t, and an x. It should have been an equation that simply relates any arbitrary coordinate t comma x to any arbitrary coordinate t prime comma x prime. That's what the equation should have had. What he has instead, he has already replaced x prime with the primed coordinate of the primed clock, and he's replaced x with the unprimed coordinate of the unprimed clock. Now it should be noted that x, the unprimed coordinate of the primed clock, is x, well, x sub c plus vt, vt minus tau, actually. So at time tau, this should be at x sub c, so that would make that the equation that we have there. So he's actually already plugged in values for the primed clock here. So let's be very clear here that equations 5 and 6 and 7 and 8 that equations 7 and 8 are not the Lorentz transformations. They are the transformations for the coordinates of the primed clock. Real quickly, when you do that, you end up with a 0 over here. Because you're using the primed coordinates of the primed clock, you get a 0 over here. And you can actually solve this equation, letting that be 0, with delta x. The bottom row leads to this, and it actually ends up, you can actually solve it, that, the x for the primed clock is, of course, the x of the unprimed clock plus v times delta t. And you can also end up solving the top row, and you find that the primed clock's change in time, change in t, is equal to the change in t. Wait, this is the change in t prime. That's the actual reading of the clock compared to the coordinate time. And the reading of the clock goes slower than the coordinate time by a factor of gamma. But if you try the other clock, the one that is stationary in the unprimed frame, you find, where does the 0 go? The 0 is over here. The x of the clock minus x of the clock is 0. And that ends up being over here. When you solve that equation in the same way, you end up with the change in the actual time on the clock is over here. The time on the clock times gamma is equal to the primed reference frame time, or the time in the primed reference frame. It's sped up. Our clock is fast compared to their reference frame. Their reference frame is different from the clock. It's a different. So you can think of it this way: those clocks are moving. They're desynchronized. So the ones over on the right are ahead of the ones on the left, and also they're moving past you very quickly. So while these individual clocks may be ticking forward slowly, so that one clicks to 11, 12, 13, etc., as they pass by, you actually end up seeing the 13 faster than the 4. You actually end up watching the one right next to you being. You're not looking at the same clock at every moment, but you're looking at the clock determining the time of the coordinate system, and that clock, the actual identity of that clock is changing, and so it ends up being that the clock identity time that is at your location is actually moving forward in time faster than your own clock. All right, I think that sums up my work on J.H.Fields' paper, and I hope you got something out of it. Thanks for watching. Ta-ta for now.